Jel vidite ekran i da li me čujete? Halo. Okay. So let's start. Thank you for attending my SQL Server and JSON. And this session will be a little shorter than usually because it's a minimum 1 hour. But for this event, I arranged a shorter version of this session. So I'm a data platform MVP from Croatia, working in SPAN. I'm leading the Croatian SQL Server user group, and from 2019 with some friends, I am organizing SQL Saturday events in Croatia. Also, I am a co-founder of Data Weekender conference. Agenda. Here are some of main topics of this session. So first we will say a few words about JSON, and after that we will find the possibility and ways to convert SQL datasets in JSON format, and also how to read JSON in SQL. How can we modify JSON data, and at the end some tips and tricks and cool things. So as you probably know, JSON is JavaScript object notation, is a language independent open standard format for data exchange between application and services. You can store data in JSON format. JSON format is simple and very popular. It is commonly used for example in Ajax applications, web services, REST, NoSQL databases, and in simple words, JSON objects are human-readable list of key value pairs. So on the right side of the screen, you can see an example of a JSON document. JSON supports only 3 basic data types, so string, numbers, and Boolean values, plus, of course, the null for representing null values. All other data types should be casted in one of these. And as you can see, there is no, for example, date data type. Dates are represented and processed as strings. A JSON string is a sequence of Unicode characters surrounded by double quotation marks. Special characters must be escaped. Here you can see the escaping rules for special characters, and control characters are always represented by the backslash plus U and the code of this character. Okay, here you can see the representation of customer record, both in JSON and XML format. At the bottom, of course, you can see the SSMS result set of the same record. Compared to XML, JSON format is less verbose and easier to read. JSON object usually contain less data than the XML object itself, and it's more adequate for network transfers, meaning less data means faster transfers. JSON format contains less text than the XML format, and data in JSON format are represented by arrays and objects, while XML is a tree structure. XML can store more complex data type, and it's more robust than JSON. XML can store additional information, and JSON can store only data. The advantage of XML is that actually SQL natively supports XML data type, and JSON can be stored only in n varchar data type, and you also have the problem or the disadvantage that, for example, you cannot easily index JSON data, and for XML you have a natively supported indexes. And also JSON data, because they are nvarchar max, they use more storage space than XML. So you maybe should think about compressing it or something like that. The main question is, why would we even support and use JSON in SQL Server? And like XML, JSON is a standard and it should be supported. Other vendors also support it, for example, PostgreSQL, Oracle, and many others. And for example, some of them, such as PostgreSQL, are very serious and robust. Many different frameworks in these days use JSON, for example, web services, applications, etc. So how can we convert SQL data type, SQL datasets to JSON? It's pretty much like creating XML data in SQL Server. You know, for example, then you can use for XML for that. In SQL Server, you can use for JSON for that in the select statement. There are two modes supported. The first one is for JSON auto, and the JSON output will be formatted automatically. And the second one is for JSON path, and the JSON output will be formatted by the query itself using aliases. And its purpose is to create more complex output, like, for example, nested objects. You have 3 additional options. First one is include null values. And normally, null values are not mapped to JSON property. So with specifying include null values, you get actually the null value. Second one is root. And similar to for XML root option, you can use the root option to add a single top-level element to the JSON output. And the third one, it's without array wrapper. And using the without array wrapper option, we can format the result as a single object. And we will see that later in the example. So because of limited data types using JSON format, SQL Server will convert data types by the rules visible in this table. Data types that are not supported by JSON in SQL Server are geography, geometry, and CLR-based user-defined data types. And so you must actually find a way to cast this data in something else. Okay, let's jump on the first demo. So I will try to select gin tonic as a drink for using JSON auto. And in this example, we will get an error because when using for JSON auto, a table is required. Okay, let's find the table and try to select all the data from customer table. And also we will get an error because the customer table contains some geography data type and geography is not supported. Okay, let's try to do the same with using XML, and you will get also the error because geography is also not supported in XML. Okay, and now we are using only some columns, and none of this column is geography, for example. So we should get the result in JSON, but this is not the case because, as you can notice here, we have the get date column that hasn't a name. So it's actually required to have alias on every column. And finally, a good example, I will use some editor here to display you the result more readable. And as you can see, these are the first 5 records of the customer table in JSON format. Special characters are escaped by rules that are specified, and everything else is here. Okay. So, okay, this was an example of XML, but you probably know how the XML data types looks. So it's pretty similar like JSON, but it's the object itself is larger because you have this closed items. Okay, the second approach to convert SQL Server data to JSON is with for JSON path. And if we try to select this, we will get actually a good result because the for JSON path does not require a table. Okay, so if you want to create more complex data types like nested objects, you can use for JSON path. And notice here that actually by using aliases, we can create more complex objects. So let's take a look in the editor, how it looks. And here notice actually that I specify that actually we will have a contract object, and after that we have the phone and fax for every item in the row. And this was accomplished by using contract.phone, contract.fax. There is also one limitation, for example. So if we actually decide to have here 2 values nested, and after that other objects, and then we want to give another nested property, we will get an error because all nested items should be one after another. So, for example, this is working while the example of before wasn't working. Okay, let's see the options. So the first one is with null values. So actually I have here created a variation of data with some null values. And let's see this in the editor, how it looks like. So notice here, for example, that customer number 2 and customer number 5 don't have the website URL because I changed in the code that actually I want to get null values. So these items are properties are totally ignored and they are not visible in the document. And if I want to get them, then I must specify the additional options, include null values like visible here. And after I run this code and return to the editor, you will see that now the customer number 2 and 5 has the website URL also here, but with null value. And this is the meaning of include null values. Okay, the second option is root. So I want, for example, to give this JSON document a root node. No, this is the original one. There is no root element, for example, but the new one, by using the root options, has here the root element customers, and then this is an array of customers actually. So when you need a root element, you can specify the root options like here. Okay, what is the without array wrapper? Let's run this code. Notice here that actually we had this array wrapper, and because this is actually an array of 5 customers, and without array wrapper, this is lost. So this is actually not a valid JSON array, because you should have this, but the without array wrapper ignore this this value. And so maybe you are thinking like myself, okay, it should be cool to use the without array wrapper and also to add a root node customers like before, to combine these two to get a valid result. And if I run this code, you will get an exception, because without array wrapper cannot be used together with the root option. And this is still not implemented from the beginning to SQL Server 2019. And I'm not actually sure why this is not implemented. Okay, let's return at our slides. So if you have a JSON object or document and you want to convert it in SQL format, you can use the OpenJSON function. It is a row set function, actually a table value function, and it returns an object that can be used just like a normal table of view. And depending on the usage, it can return data in 2 possible ways. The first one is with default schema, and the second one is with explicit schema. So default schema meaning when the schema is not, of course, specified, and explicit schema is a user-defined schema, meaning that the user specified the return data types. Okay, OpenJSON with default schema. When you don't specify the schema, for the returned result, the OpenJSON function returns a table with only 3 columns: key value and type. Key, this is the name of a JSON property or the index of a JSON element. The data type of this column is nvarchar 4000, and the column does not allow null values. Value, this is the value of the property or index defined by the key column. The data type of this column is nvarchar max. Nulls are allowed, of course. And the third one and the last column is type. And this is the JSON data type of the value. The data type of the column is tiny int. And you can see in this table at the bottom the possible values for this column and appropriate descriptions. Let's jump on the second demo. So OpenJSON with default schema. I have here a JSON document, valid, and I want to select star from OpenJSON, and I'm passing the JSON document. And of course, I get an error. And notice actually, I will paste this document in my editor. And notice here actually that I have an error here because the name is not closed. So this is actually a not valid JSON document. And SQL Server told us JSON text is not properly formatted. unexpected character J is found on position 11. So this is a good approximation of the location of the error. So actually is this J, but the error is actually before a little bit. But you can actually get, you can analyze the document and find with this hint where is the actual error. Okay, now a good example. So I am selecting select star from OpenJSON and passing the JSON document again. I get 3 columns, key, value, and type as described. So the key is the name of the property. The value is the value of the property itself. And the type is the type from 0 to 5. And it's a little harder to read maybe. So I created a small test function that will return if the JSON type is 0, then it's null, 1 is string, 2 is int, whatever. And when selecting this, we will see actually then John Doe is a string, that 1979 is int, and whatever. So meaning 2 is int, 1 is string, and etc. Okay, with JSON, we can, of course, select only some nodes. So I have here parents, for example, and I am passing 2 arguments now in OpenJSON. So the first argument is always my variable containing the JSON document, and the second one is the path that I want to retrieve. So by doing this, I will get only this parents node and of course the 3 columns. Okay, I will get 4 columns because I wanted to easily read what data type is this. What will happen if we try to select the non-existing friend node in the JSON document? We will of course get an empty table result because the friends doesn't exist. Also, when specifying the path that you want to retrieve, you can use the strict option. And what will happen now? We will get an exception because the friends node does not exist. So strict is cool for some data validations, constraints, and many other things can be used. So it's strictly defined that this property should be in the JSON document. And if it's not contained, then you will get an error. Okay, let's select favorite drinks. And notice here that favorite drinks is an array of a complex data type. So actually the result here is complex, meaning you have object data type. And if you want to get some values, you must read this in other way. Let's try to see also we have the favorite drinks, and I want to read the favorite drinks, but notice here the space, because space is of course allowed in the JSON document. And if I try to read favorite drinks with space, I get an error because this is not well formatted. And if I have spaces in the name of the property, I must, of course, close this by double quotation marks. And this is the way to select the property with space in the name. Okay, let's return to the slides. OpenJSON with explicit schema. It's something similar, of course, like reading XML data in SQL Server. We can specify our own schema when reading JSON data. In this case, the function will also return a table, but the output columns and their data types can be specified by the user itself. The schema for the JSON data can be specified using the optional with keyword at the end of the OpenJSON function. And let's jump on the demo. So this is another query. We have our standard JSON document, and I want to specify the schema by myself. So I'm using OpenJSON. I'm putting the width, meaning that I will specify the schema, and I'm specifying here the columns and their data type. So the name is varchar, for example, of this size. Born is int, like suppose, okay, varchar. Favorite drinks is varchar max as JSON, because this is actually a JSON document. And let's select. Now notice, of course, that we are not getting 3 columns like before, but we get as many columns as we specify in the width part. Okay. What will happen actually if this favorite drinks that was specified as JSON, because it's complex data type, we try to select but without this as JSON. Notice here that we don't have as JSON. Let's check it out. And the result of that is actually that the whole favorite drinks is returned as null. So the value is ignored. Okay. Let's try to run this example and see what actually happened. We get an error, and we get actually the error, notice, because we specified favorite drinks like varchar max and as JSON. So this is not allowed, because if a data type is a column is of type JSON, it must be an varchar max, like before here. So it is required actually that you use varchar max. And for example, if we want to get these favorite drinks for every person here, for all the favorite drinks, I can use this cross-apply OpenJSON and pass the favorite drinks. So firstly, I was selecting favorite drinks like JSON, and then I'm using this return column with OpenJSON, and I will get all my favorite drinks. So I get cold water daily, coffee and milk daily, gin occasionally, okay, daily, and so on. Okay. We have some functions for using with JSON. The first one is JSON value. And this is one of the 2 functions with the purpose to extract values from JSON text. The second one is JSON query. And JSON value is used to extract a primitive data type. So actually only null, string, number, or boolean. One important limitation of the JSON value function in SQL Server 2016 is that a variable as a second argument, JSON path, is not allowed. From SQL Server 2017, this is supported. So actually you can use a variable for the second argument. If the extracted value is longer than 4,000 characters, the function will return null or an exception. So in lax mode, it returns null. And if you are using strict mode, you will get an error. JSON query, as told before, is used to extract JSON fragment or to get a complex value data type. So only arrays and objects can be retrieved with JSON query. The function returns JSON fragment of type varchar 4000. The collation of the returned value is the same as the collation of the input expression. And if the value is not an object, in lax mode you will get null, and in strict mode you will get an error. Okay, so we have our document still, and I am using selected JSON value, and of course I am passing every time the variable and the path to this. So let's see what will happen. I get, of course, all these values. The non-existing node, it doesn't exist in the document. It's returned as null, for example. Okay, and what will happen if we want to extract value more than 4,000 characters? So as told before, in the relaxed mode, I will get null. And if I am using the strict mode, I will get an exception. Okay. And JSON query. JSON query is for extracting only complex data types. So basically in this example, only the favorite colors are returned because favorite colors is complex data type, and only this value can be written with JSON query. And all others are returned as null, of course. And if you try to use this with strict mode, you will of course get an error because it is required that actually every item returned by JSON query in strict mode must be a complex data type. So you can also use this JSON query for some validations and etc. Okay, modifying JSON data. So you are using, for that you can use JSON modify, and it allows you to update the value of an existing property. For example, you can also add a new element to an existing array. You can insert a new property and its value, and also you can delete a property based on a combination of modes and provided values. How you do multiple changes? Of course, with multiple calls of this function. Let's jump on the demo. Okay, I have two small document with only two properties, and I want to add currently presenting. Like, my intention is actually that I get true here, and actually the result is not like I was hoping. I get the new node currently presenting, but this is interpreted like one, like a number, of course, because SQL Server didn't know what are my intention. So if I want to get a valid data type, I must pass to the function of this data type. So I will first need to cast this as bit. If I do this, I will finally get a result I was hoping for. So like true. When, if you try to using strict here for adding a new node, you will get, of course, an error because strict forces that the property is already there. So with using strict, you can only change the property value and you cannot add a non-existing value. Okay. I have here our document. I want to add an array actually about two meetups that I have, for example. And notice here that actually meetups here are representing as a string. So also I didn't get what I was looking for because this is not an array. I was hoping to get an array, but this is not an array result. To accomplish this task, I must actually specify this as a JSON query. So this variable I am specify like a JSON query. And if I do this, the result is finally a JSON array. If I passed this to my editor, you will see that actually the meetup is a valid array. And if you want to accomplish this, of course, you must use JSON query. If you want to remove one node, it's simple because you specify the name of what you want. I want to remove favorite drinks, and you pass the null value. And by passing the new value, this property will be removed from the JSON document. Okay. Let's try to remove the only first element of the meetup list. So I am trying to remove meetup 0. 0 is of course first. And it's not totally removed. Notice here that it's actually set to null. And we still have two objects, two items, sorry. And the first one is null. If I want to get to be totally removed, I must actually pass a totally new array with all the elements containing. So now this is totally, of course, removed. We don't have two elements, but only one element in the array. Okay. I can use this, of course, to update something. So I had here new SQL Server functions, and I replaced this with something about SQL functions. So this is a way to accomplish the change of an item. We can, of course, append an element, and it is, if you want to append an element, you must write append, the name of the node on which you want to append an element, and now I get the third. What if I want to append a value to a non-existing node? It's cool because SQL Server did actually create a new element and did put the first value, searching about new SQL Server functions. What will happen if we try to update something in null by using strict? Of course, it's working because favorite drinks is removed, but only the value is removed. So the node remains here. And this is also cool if you need this. If you want to make multiple changes, then of course you must have multiple call of the JSON modify function. And this is something like, if you remember the replace function. And this is the way for multiple changes. And let's jump on the last slides. So you have actually two functions. The first function is JSON, and it checks if the input string is a valid JSON data. It returns an int value with 3 states, so 1 for yes, 0 for no, and null for null. But each JSON does not check the uniqueness of keys at the same level. So actually notice here this example here with 2 names. And if you run the isJSON here, you will not get an error. So this is a valid JSON document for SQL Server. And some tips and tricks. You can, of course, import JSON from a file on your hard drive. let's see how you can index JSON data and maybe a cool example at the end. Let's jump demo. So is JSON, let's see. I have 3 values here. The first one is null. It is returned like null. Is JSON for something that's not a valid JSON document, I get 0 because this is not valid JSON document. And in the third example, I get that actually this is a valid JSON document. But maybe you are a developer more, and maybe you know if this is or isn't a valid JSON document. I am really not sure, but from my point of view, isn't, because maybe here can be written something else. And now we have a dilemma, of course, what's the correct value for the name here. But if we run this in SQL Server, we will get 1. And from the point of SQL Server, this is a valid JSON document. Okay, of course, you can use this function for check constraints. So imagine a case, then actually you want to store in a table in the database app settings, and this must be a valid JSON document. So you can actually create a table with check constraints. And I created this table. I want to insert 3 rows. And I get something like an error here. Let's check what happens. So only 2 records are inserted, the null one, because I didn't check if the value is null or not. So null is accepted, and also the JSON is accepted, and the insert fails only on the second row, which is not a valid JSON document. I have here on my hard drive some JSON in the file, and I can use, for example, bulk insert to read it. And this is really cool if you want to import large JSON documents. Okay, let's see something about indexing JSON data. I have already before created some test table with JSON documents, and I want actually to retrieve all records with the city name Idaho City. If I run this select, I will see actually that the whole cluster index scan, the whole table is scanned, and this query took about 16 milliseconds. Okay, it's a small query, of course, and notice that the table JSON indexing had 75 logical reads. So this is not performing very well. I will then, I created a computed column, customer city, and I am using JSON value to extract this. I will, of course, create an index on this column. And when I try to select right now on this calculated column, now notice actually that the execution plan is much better. So I have index scan. I am using my created index for that. And of course, key lookup. And notice in the messages that now I have only 7 logical reads, and that this was performed in, okay, 0 milliseconds. Maybe not really, but okay. The second hint to use JSON, you can create full text catalogs, for example. So this gives you the possibility to actually use the full text contains Idaho City. And notice that the table value function full text match was used, of course. And this query was also very fast performing, and we have only 2 logical reads. Okay, I will clean that later, since I have around 1 minute to finish. The JSON function and approach is really cool in some cases. For example, a boss come to you and tell you, okay, I have a large table for you, for example, sys databases, because it has 86 columns. And please give me only the columns that are not equal in these two rows. By using JSON, this is pretty much cool because we actually can see that only in these 9 columns, the values are not the same. So when comparing, for example, master and model database, these are only columns out of 86 columns that are different. Notice here that you have really 86 columns, and if you want to compare 2 rows, this is not so great. You can also use JSON to process comma-separated list of values. You can do it by this example, but this is not so great because you must have the good formatted document. And one last thing, and I am really done then, is that actually JSON is really cool. For example, if you calculate the column hash code by using hash bytes of the whole table row, all columns from a table, converted to JSON auto. And if, for example, in the production, you must synchronize data between 2 systems, you can, for example, compare them by the computed hash code. And this is really fast performing by not, there is no need to compare records by every value in that. And sorry that actually I took more time, 2 minutes, and thank you very much for participating on this event. Are there maybe any questions or something? All of you are in shock, or what's happening? Okay, I will mute myself. Thank you. In 10 minutes, Thorsten Strauss is starting with parallelism in Microsoft SQL Server. So let's wait for Thorsten. Bye.
Hvala ti puno na sessionu.
Nema na čemu, bilo mi je zadovoljstvo, nadam se da je neko bar uživo i da je bilo korisno. Hvala vama što ste me pozvali. Bog.